Welcome back to Mrs. Riley's maths videos, and today we are looking at the sphere. The sphere, an example, I have one here with me. I'll just lift the camera up a bit. A sphere is like a golf ball or a soccer ball or a tennis ball, anything like that. You know what a sphere is. Basically it's a ball. It's also, as I found today in my kitchen, like an orange. Okay, oh, dribbling orange juice on my page. So it's like an orange. Okay, and there's two things we have to do with this sphere, is that we have to be able to find its volume, and the formula for that is in your tables book. It's 4 over 3 pi r cubed, so 4 over 3 times pi times the radius cubed, and the surface area, which in this case would be the skin, so the volume would be how much orange is in this orange that you can eat, and the surface area would be the skin, so the orange bit that you can see, and it's 4 times pi times r squared. Now you also need to be able to deal with a hemisphere. So a hemisphere, here's a hemisphere. Now it always amazes me that people kind of get confused about the hemisphere. I'm not quite sure why. I think maybe because they think it should be called a semisphere, which is what some of my students have called it in the past. So a hemisphere, which is a semisphere. And so I thought I'd cut this orange in two. And when I cut the orange in two, I get two identical, hopefully, hemispheres. Now, the volume of the hemisphere is fine. Like the volume of a hemisphere is obviously just half the volume of a sphere. So that'd be a half by 4 over 3 by pi r cubed. And a half by 4 over 3, as I hope you know, is a half of 4/3, which would be 2/3 pi r cubed. So the volume of a hemisphere is fine. But where people fall into difficulty is this surface area of a hemisphere. Now, let's go back to our sphere. So here's my hemisphere, my sphere I mean. Oh, cut it in two. Currently the orange part, the visible orange, that's the problem with the fruit and the colour being the same. The visible part of the orange, if I was to cut it in two, well obviously I've got a half of that now. So the curved surface area of a hemisphere, this orange part here, is going to be 2 pi r squared. Okay, because it's a half of 4 pi r squared. But then you've also got this flat bit on the top, the juicy bit that makes you want to eat an orange now. That's another circle. So it's got 2 pi r squared, then plus the top flat circle. So that's another pi r squared. So the surface area of a hemisphere is actually 3 pi r squared. You've got half of the sphere, which is this skin bit, but you also have this flat surface on top, which is also part of the surface area, and it is a circle as well. So altogether it's 3 pi r squared. So what we have here is that the surface area of a hemisphere, surface area, is 3 pi r squared. So surface area of a hemisphere is 3 pi r squared, and volume is 2/3 pi r cubed. So we should highlight all these in orange. Okay, and then we have the sphere, which for some reason I'm highlighting in green, which I've lost. The sphere is, the volume is 4 over 3 pi r cubed, and the surface area is 4 pi r squared. So let's do some examples. Not a particularly difficult formula to use, especially seeing as you have a calculator for your fractions. So 4 over 3 pi r cubed is the volume. So for instance, you've got a sphere, and you're told that its radius is 10 centimeters. You're asked to find the volume. Now, do you notice with the cylinder we had radius and height, so we had two measurements that we needed. With the sphere we only have one measurement, which is the radius. I should have kept the orange, sorry, I went away with it. The radius of a sphere, or the radius of a hemisphere, is that distance from the very center to the edge, as you'd expect really. Okay, so how we show that is we show we try and show it on our diagram if we can. That's the radius. So radius here is 10. The volume is going to be 4 over 3 by pi by r cubed, so 4 over 3 by pi by 10 cubed. And if I use the pi button on my calculator, then I'll just work it through. So using my fractions button, I've got 4 over 3 by pi by 10 cubed, which is 4188.79. So let's say 4189 centimeters cubed. The surface area of the same sphere. So the surface area is 4 pi r squared. So in this case it's 4 by pi by 10 squared, which as you can see is 400 pi, which will be 400 by pi is 1256.64, so 1257 centimeters squared. Okay, so it's not hard. Just remember all the time, name your shape, so it's a sphere, name whether you're trying to find the volume or the surface area, make sure you write down what your measurements are that you're given, and if at all possible, sketch the shape. Okay, so what about first hemisphere then? So here we have a question that says find the volume and surface area of a hemisphere of radius equal to 24 centimeters. Okay, so find the volume and surface area of a hemisphere of radius 24 centimeters. So what do we have? We have a hemisphere, so let's draw a picture. Here's our hemisphere. The radius is 24. There we are. Just a quick side point, and in this hemisphere, any line that goes from the center out to the edge is going to be a radius. So all of those are going to be 24. Now where that comes in handy is this one here. So sometimes we'll end up having to find the height. This one here. Do you see? Sometimes you have to end up finding the height of the hemisphere. So just a side note here. Side note, the height of the hemisphere equals the radius of the hemisphere. So just remember that for future reference. Okay, so here's our hemisphere. Find the volume and surface area of a hemisphere of radius 24 centimeters. So volume hemisphere is equal to a half of the volume of the sphere. So a half by 4 over 3 by pi r cubed. Now this formula is not in your tables book. The one for the sphere is, the one for the hemisphere isn't. So you just have to remember that a hemisphere is half a sphere. So here's the volume of a sphere, and then half of it. So it's 2 over 3 by pi by r cubed, which is 2 over 3 by pi by 24 cubed. Just do it on the calculator then. So 2 over 3 by pi by 24 cubed, which is 9216 pi centimeters cubed, which is, it's a big number, 28,952.9 centimeters cubed, which is 28,953 centimeters cubed. So that's the volume of the hemisphere. Okay, so then we have to find the surface area. And remember what we said about the surface area of the hemisphere is that it's made up of half of the surface area of a sphere plus the top flat circle. So it's 2 pi r squared plus pi r squared, which is 3 pi r squared. So in this case our radius is 24. So the surface area of this hemisphere is going to be 3 by pi by 24 squared, which again I'm going to do in my calculator. 3 by pi by 24 squared, 1728 pi centimeters squared, which is 5428.67 or 5429 centimeters squared. Okay, hope that helps. I'm going to do another video with working backwards on these. Thank you. Bye-bye.